Hi everyone, welcome back to our YouTube channel. So today we've got Volkan, who has just completed the course Linux Basics, and he'll be giving us a presentation about that. So first of all, we'll see a demonstration of his code base running on a real robot, and then we'll get to see the simulation. And then after that, we'll get into the details about how he managed to do his project, and we'll end up with a couple of questions. So I'll now hand over the platform to him so he can begin his presentation. All right, whenever you're ready, Volkan.
Okay, sure. Yeah, first of all, I have to start the robot. Okay, so I'm going to present now the obstacle avoidance program I wrote for the robot. We just have to wait until it's connected.
Okay.
Okay, it's taking its time.
All right.
Okay,
Okay, finally.
nice. Okay, now I'm going to execute these commands for the robot as well. Okay. On the web shell. Okay. Oh, yeah. Okay. And now we see the sensory data of the robot. I will also run this on the web shell. So if anything happens, can also just make the robot stop moving.
Okay. All right.
Yeah. Okay, now I will start with the project. First, I'm going to start the robot interface. This is a Python program. Okay. We will come to that also later on in this project. So that I'm going to start the avoider, which is written by myself. Okay, after that, the last thing I'm going to, start is the statistics dash, just to see some statistics of the robot. Okay, now we can see the robot is moving. There's also some graphical tools, so you can see that he's avoiding obstacles. Might take some time to move, but yeah. Okay. How long do you want to see this? Or should I just go into my program? Here we can also see what he's doing.
Just maximize your screen a little bit so that we can.
The robot, or what do you mean exactly?
The robot window, yes. All right, let's see. Is it moving yet? No, it's not moving.
It was moving a second ago, but here. So no, he moved. Yeah, my laptop is a little bit slow. Maybe this is the
Okay.
reason why it took some time.
So what I would suggest you do is you pause the execution. Okay, now it's moving again. I think there's a lot of lag.
Yeah, I'm sorry about that. I'm just with my laptop here.
Okay.
He hasn't the best power.
It's fine. Let's leave it for a little bit, so we see it actually avoiding obstacles, right?
Yeah, sure.
Or maybe you can refresh the window a little bit, I think, on the top right. Oh, there we go, it's moving, don't worry.
Okay.
Okay.
Yeah.
Okay.
I'm sorry about that.
It's alright. I'm quite keen to
Yeah,
see
it
what it
did.
does after that, because there is an obstacle in front of it. Okay,
Okay.
there it avoids it. Okay.
Yeah, only one window is moving right now.
Okay, I see. Yeah, probably.
Yeah, he's avoiding it.
Okay.
You see the right one? He's
Yeah.
turning left.
Yeah, I see the right one is the one that's moving. So we keep looking at that one. We'll forget the left one.
Yeah. Ah, okay, the left one is moving now. Yeah, they are switching. I don't know.
Okay. Let's see if it avoids the wall.
Maybe yeah.
Yeah, okay.
Looks like
There
it.
we go. Yeah, it's rotating. Okay, that's good. Okay, now the left one is more consistent, so it's okay. I can see the lasers can spin.
Yeah.
Alright, I think okay, we'll just let it move for one last time and then we can go to the simulation, yeah.
Okay. So like this or
Okay, there you go.
the okay.
Yeah, it's fine. I think let's go for the simulation to see if it behaves any
Okay.
differently. Obviously it will, right? I hope.
Yeah.
uh,
Yeah, this
okay, but
this is a rather old laptop.
at least we have
But,
seen that
okay.
it does avoid obstacles, yeah. So we just wanna check the simulation version of it.
Okay. Okay. You want to see the simulation version as well? Okay. Then let me maybe stop all of this so I can run it again. Okay. Okay. So maybe yeah. I have to start the gas bowl first. The simulation. There was um, a command. I'm not really sure where exactly it was. Here, launching in the simulation. It is all right. Yeah. Okay. Yeah. Now it should connect to the simulation. Yep. Okay. Connect with guacamole. That's nice. Yeah. There's the sensors. Maybe I should zoom in a little bit so you can see the robot a little bit better.
Yeah, that'd be good.
Okay. Wait. Okay. Think that should work, right?
Okay. Yep.
Okay. Okay, now I'm going to execute this on the simulation. So this is this one, right? Okay. No, this is already on there. That was unnecessary, but okay. Interface is the first one. He's getting ready. And he should be ready. Yes, okay. And the next one is a simple patrol bash. Yes. And after that, oh, I think that was the wrong one. Sorry.
Okay.
Yeah, sorry about that. Yeah, this is the real one. The interface was correct, but this one was wrong.
Okay.
We want to see the obstacle avoider, right?
Yeah.
Yeah. Okay, this should be right now. And last but not least, the statistics. Uh, mm, okay. Now we can see in the simulation and the graphical tools, the robot should
Start
move,
moving. Yeah.
hopefully. Okay. Maybe.
Okay.
Yeah,
It's moving.
he's
Yeah.
moving. It's just slow.
Okay.
Okay.
Let's see the out of his window. Okay. All right.
Yeah, it might take some time. I have maybe put the sleep parameters too high. I'm not sure.
Oh, okay.
Or
Okay.
my my laptop is just a little bit slow. One of the
One of the two.
two
Okay.
things. Yeah.
Yeah. Maybe it is stopped. So my assumption is that it slept. I think. So let's see. If it's gonna wake up soon. Oh, now it's rotating. Yeah.
Yeah. Okay.
I wonder what made it rotate. What did you set your threshold to be?
It was only 0.3.
Okay. All right.
So this is very weird. Usually it should just move
Just
forward
continue.
like the real robot did.
Yeah. Yeah. Oh, but
Yeah.
it's probably because something with the map. But we'll see.
Okay.
Okay. That side
Yeah.
should be open. There should be no obstacle there.
Yeah.
Keeps rotating. Can you get it to start from a different place?
You mean from different viewpoint or?
Nah, move the robot to a different place. Let's see. Yeah,
Yeah,
because
this is very weird.
the fact that it keeps rotating, it's thinking, oh, there are obstacles everywhere, right?
Yeah.
Okay, can you restart?
Yeah.
Restart the
Let
whole
me
thing.
restart.
So
I will just restart everything. Okay. Okay. Then let me start the guest pro again from the beginning.
all right.
Yeah, okay. Okay. Yeah. Okay, that was quick at least.
At least we can get to see it moving a lot quicker. I hope.
Yeah, I hope so too. Okay. Okay, now we can see the robot. There are the obstacles, okay. Then I will start the obstacle avoider. Yeah, first the interface. Take some time. Okay, he's ready. Avoider. Okay, and last but not least, the statistics. I hope it works properly now. Maybe. Wait. Okay, now we have to wait.
All right.
Let me check the obstacle avoider. Okay.
Okay, it's moving.
He's moving forward, but I think there's a bug in the
Yeah, because
sensors.
I think it's the
Yeah.
the localization that's not proper with that one. So
Okay.
you can okay, but it already started moving. We could have tried to give it a pause estimate, right? So that we just give it an approximate location of where it is on the map. But
Yeah.
fine. Let's see it moving for now.
Okay. Yes. Okay.
It's just the map that's faulty because I see that on the.
Yeah.
Okay, it has reached the wall, so the sensors are working properly. But let's see if it rotates either way. Okay, it gives you left range. Okay, right range. Oh, okay. Front range. Okay.
Yeah. He's turning around.
Turning
That's
right. Okay.
that's good.
Okay. Yeah. Then the
Yeah.
sensors
Take
are
some
working
time.
fine. Yeah. Let's see. Okay. I think clearly it's lost because it thinks there's something in front of it, right? Because the red dots are saying there's something.
Yeah, for some reason. I don't know why that is no problem. Or is it moving forward now? I don't know.
Alright, just hang on. Let's wait for it a little bit.
Yeah, that was not a problem when I tried it, but yeah, bugs can happen anytime, I guess.
Alright. No, it's fine. I think we can stop the simulation now and we'll just get into the details about the Linux stuff.
Okay.
Alright, so walk
Okay,
me
then
through
let
your code
me.
base and what you did.
Yeah, sure. Uh,
Yeah, you probably might
let
have to go slightly
me.
quickly because I've got 5 more
Yeah,
minutes. Yeah.
I'm. Okay, okay, okay. I'm. going quickly through it. First, I will go through the obstacle avoider, which I wrote myself. So first, I imported the robot function bash, so I could use some methods. This is the shebang line, so it knows it's a bash from Linux. These are just some terminal things. So this is the start of the robot, no rotation, no movement. This is the threshold, so the robot knows when there's an obstacle. I'm rushing a bit through it now, so because
Yeah,
we
it's
have no
fine.
time.
It's fine.
This is
I'll stop you if there's
why.
something I want you to explain more.
Okay, this is the while true, so it goes on as long as I don't hit the Control C combination. Here I get all the scan ranges. So this is the left scan, this is the front left, this is the front, this is the front right, this is the right range. I use it to, I save them into variables.
Okay.
So, and this is how I check if the front left is blocked, the front is blocked, and the front right is blocked. I just check if the range is smaller than the threshold.
Okay.
The left range, normal range. I use this because these are float numbers. Yeah. Okay.
Okay. All right.
And here I check if everything is blocked. If it's blocked, then yeah, I should turn left. If the left range is bigger than the right range. Here's also the sleep and the angular, which I set. Yeah, first I had some problems because I didn't use them. So the robot was already executing the next commands before actually finishing the last one. So this is actually crucial.
All right. All right.
Yeah, here this is the same. Just if the range right is bigger than the left, then he should turn right and not left. Yeah, and this is if the front right isn't blocked, then he should turn right because obviously it's free. And the same with the front, he should just move forward. Here he's calculating the distance he should move forward. And this is the time he's going to move forward. So this is also subtracted by 1 second. So there's a little bit of a delay. So everything runs smoothly. And yeah, this is just some terminal stuff. And this is the speed. And he's sleeping as long as he's moving. So he doesn't do any other things.
Okay, for as long as
Yeah, this.
All
Yeah.
right, I see. All right.
And
so anything else?
yeah.
All right, let's go.
This is just all the. Yes, should I can try to be faster. So this is if the left is blocked, you should just turn right. If the left is blocked, turn right. Yeah, and if only the front is blocked, he should also turn left. Or if the left range is bigger than the right range, else he should be turning right. And if the front right is blocked, he should turn left. And if nothing is blocked, he should just do the same again, just move forward. This is the same logic as before with movement speed and the distance to move. Yeah, and this is the end of this obstacle bash.
Okay.
I can also. Do you have any questions, or should I just continue with the robot interface Python?
Yeah, just run me through that before I ask the questions. I think I will let you explain that one first.
So this is the shebang line for Python. So Python P, so it knows it's a Python file. These are all the imports used for the ROS2 nodes. So this is creating the ROS node with the name Robot Interface. this is so the parameters can be changed later on, and if there are parameters, they automatically will be used for that node. Yeah, this is just this whole thing is the initialization of the ROS node. Everything's set to 0. Yeah, he's creating here a publisher with the topic CMD val. Here's just some initialization callbacks. So more callbacks are allowed. For example, there's another subscriber here. Nothing special here. Just declaring an initialization, the position for the subscriber as well. So all initialization. And here's the destructor. So if the object or the node is destroyed or closed, this is going to be executed and nothing's in return. These are the global variables just used for example, pi is always 3.1410. So everything's also here set to 0 at the beginning from the front array index, for example. So these are just the global variables.
Okay, no, that's fine. I think that's all right. What we mainly wanted to understand is, do you know what the node is doing? So that's all right. You've shown that you do understand. So, what are you doing with the base script? Right. What exactly are you doing with the base script in relation to this file that you've shown me?
What exactly do you mean? The obstacle avoider bash script or
Yeah. So
the interface?
when you start it, right, you connect with the robot interface.py with the base script, right? And you're getting your readings, or all the variables, you're getting them from this robot interface.py. So I just wanted to find out what is the relationship, right? What is it providing to you? What is this robot interface .py script providing to you?
Okay. This is providing me all the information from the robot. For example, like it's the position of the robot, or like the distance he moved.
Okay. So you just echo
Yeah.
them in the terminal when they are received by your.
Yes.
Okay, I see.
So I can read them, for example.
All right.
Like
So
humans can understand. Yeah.
okay, so I'm gonna have to ask you some other questions that are not particularly related to this, but well, it's still Linux stuff, right? So,
Okay.
just in general, what is the purpose of using base scripts, right? Why do we create base scripts, right?
Okay. Yeah, bash scripts are just a simple way to perform a lot of web shell commands in a row without doing like any mistakes. Like everything written in a bash script could also be exactly written like that into a web shell, but it's like easier to write it in a bash script so we can use it more often as well. So it's to avoid repetitiveness as well. Yeah.
Right. Okay. And then the other thing, so let's say you navigating through your Linux directories, right? How do you
Yeah.
access hidden folders or directories?
I could show you. This is mostly done with the ls command. So, for example, if I want to go into the ROS2 folder, I just go cd and go into this, and then I can do this. If I want more information, I can also do lsla to see, for example, the permissions everyone has. For example, here's the owner. The owner can read, write, execute. A group can just read and execute, and others can also just read and execute for the builds folder. Yeah.
All right. So what if you just want to see all the folders that are in there? Okay. So the one answer that I was looking for exactly is ls. Then you put your stroke a, right? So if you can do that now,
Oh, you mean that?
yeah.
Yeah.
So you see, it shows all the hidden folders, the dot and the double dots. So
Yeah.
yeah, but
Okay, I'm sorry, I misunderstood the question then.
yeah, but it's fine. It's all right. So the other question is, so let's talk more about just understanding or figuring out what processes your system is working on. Right? There are two commands that you can use. Can you give those to me? Do you remember what
To
those
do
are?
what exactly?
To list the processes that your system is working on.
Yeah, there's first of all the PS faults, for example,
Mm-hmm. Mm-hmm. Yeah.
and there's also the H top, right?
Yeah,
It was
yes,
H
that's a
top.
custom one. Yeah, yes, you can also do that. Yeah, and you'll be
Yeah.
able to see the loads, CPU loads, and everything. Okay, that's pretty good.
Oh, sorry. Yeah.
Okay,
Yeah.
so
Thank you. Thank
let,
you.
let me just check. Do I have any more questions here? No, I don't see any more questions. All right.
Okay.
I think that's it from my end. So can you just
Oh, nice.
take me through your whole project in a couple of lines? So I want to understand, what problem were you trying to solve, right? Because you did a demonstration on the real robot, you also did a demonstration on the in simulation, right? But what exactly are we
Yeah.
putting out there? What was the objective, right? Of course it was to learn Linux, but then I just want to get the general, what
Yeah.
did you have to do to prove that you do understand?
So I had to understand a lot of Linux commands, and
Mm-hmm.
I also had to understand how Bash scripts work because they're very different from, for example, C++ or Java, where
Yeah.
I usually come from. And yeah, I had to understand where the robot gets its information and how I use them. For example, the front ray, and example, and I tried to avoid obstacles with the robot. So this was the whole point of
All right,
uh,
so that's
the course.
using control loops to check for uh,
Yeah,
conditional variables. Okay, I see. I see. All right. I think
yeah,
that's it from my end. Thank you very much for your presentation, Volkan. So what we'll do is
yeah, no
we'll
problem.
wrap it up here, and then we'll finish our conversation on Zoom. So just hang on, okay?
Okay,
All
sure.
right. All right, everyone. So this was Volkan's presentation. A very warm congratulations to him for completing it successfully, and would like to encourage all of those who would like to try the courses we offer certification on to give it a shot, and then you can come and do your presentation. And until next time, keep pushing your